Okay. Let me move the, I have the, yeah. Okay, so this talk is going to be about taking the metrics for the code coverage of the JavaScript code when we run the Rails test, right? Because what I found usually hard to do is sometimes you see a good Ruby on Rails code coverage, Ruby code coverage, but then applications, modern applications may have React frontends, Vue frontends, things like that. And I think the front-end code should be tested as good as the backend code because the front-end is what the user is seeing and is interacting with. So I think we should have tests for that too. And we usually have tests for that, but we don't have the coverage for that because it's not that straightforward to get that. So before I start, I'm Ariel Juodziukynas. I'm from Argentina. I work at Labs with Ernesto, and yeah, my main language is not English, so sometimes I may pronounce things in the wrong way, but hope it's not that bad. Okay, so the first thing is, why do we want to take the code coverage metric, right? Some people want to have a 100% code coverage with no reason, just to have a good number. But I think we shouldn't just add code coverage to have code coverage. That should be a tool to help us identify things. For example, we can find things that are not tested, but it doesn't mean that we have to add a test for that line of code. That means that we have some feature that is not being tested properly. Or if we know that we have some code and we don't find a way to test that using a good, I don't know, a system test, that means that probably that code is unreachable or dead, so we can probably remove that. So that's the reason why we want to use code coverage, not to say, oh, we have a big number of code coverage, because that's not an indication of anything. Having a low number is usually an indication of a bad test suite, but having 100% doesn't mean it's a good test suite. So how code coverage works in general, right? The first thing we need to do is we need a tool called an instrumenter. An instrumenter is a tool that modifies our code to get information from the code after the execution. Then we need to extract that information from whatever is being stored during the execution of the app. Then we need to process all that data. And after something, we have the reports of all the code coverage. In this case, it's going to be for both Ruby and JavaScript code. So before we start, we are going to do some live coding. So let me show you the base application we are going to use. It's super basic. It's just an application that has some components, right? Written, some of them are using React and TypeScript. Some is vanilla React. Some is TypeScript with no React or anything, and some is just vanilla JavaScript. And every time we click any button, it will do print in the console how many times we click that, right? This is just so we have something that we can, something actionable that we can try during the test to see how the code coverage changes. And then the code application is pretty straightforward. We have an application.js pack, and it's rendering all the components that I built. And each component is just kind of the same thing. It's just rendering a button, and on click is calling a function that renders something in the screen, in the console, right? And one thing I did for this is I wanted to make sure that these things work on both Minitest and RSpec, because you don't know what's going to be in the code in the application you work on. So I added tests for here. We have some tests for RSpec, and we have a similar test, system test for Minitest. So we are going to work with both of them to see how it, because there are some differences on how we set up the things there. Okay, let me go back to the presentation. One comment there is that to use an instrumenter, we need to use, the only one I found that is production ready is Istanbul, is a JavaScript instrumenter, and that needs a JavaScript bundler like Webpack that can work, that works nicely with Istanbul. I haven't tried with ESBuild or other bundlers, but we need a bundler. It won't work with sprockets. So maybe there somebody makes a plugin or something. The thing is Sprocket, it doesn't work the same way at other builders, so bundlers. So this needs a modern application with Webpack. So the first thing we need to do is we need to add an instrumenter. So we are going to use simple code for the Ruby code and Istanbul for the for the JavaScript code. So I'm going to follow. I wrote a blog post about this process, so I'm going to follow that with everyone. So it's just so you can see that how it works and everything, and it's just straightforward. It's really straightforward. I tried to make the most straightforward solution. So the first thing we need is we need to use Istanbul. This is the library I was talking about. It's an instrumenter. So first we need to add that we need to add the package. So I'm going to do that. I'm back here in the console. I can add Istanbul. This is the loader needed for Webpack. And there is another tool that is called NYC. NYC. This is the actual instrumenter. The loader is something that we need for Webpack, and NYC is the instrumenter. So one thing that I think it helps visualize what we want to do is, let me show you what an instrumenter actually does. So let me go to this. So in the application, I created this directory called toInstrument with one pretty simple file, right? It's nothing amazing. It's just one file with a function and some branching. And if we run NYC instrument and we tell it to instrument that directory, let's do app assets JavaScript app JavaScript to instrument, and we are going to put that in app JavaScript instrumented. So after that, that will instrument our JavaScript file. And now if you come back here, we have this mini file code, but let me say that so the formatter fixes something. And what the instrumenter is doing, it's first, at the bottom, we have the initial code, right? We have the X equals something, my fun, the branching here, but it's adding a lot of calls to this function and incrementing counters. So this is how it keeps track of the execution of each statement and each function and each branch. So for example, here, when we do X equals something, on the right side, we can have a JavaScript expression. So this is just counting that expression was called once. It's incrementing that by one. Then it's incrementing this line by one. Then it's saying that this function, the first function, was executed one time. So it's incremented that number. And this is something, this part at the top is something Istanbul is adding to our JavaScript code. And it keeps track of everything. And it says, okay, the first statement is in line 1, and it goes from column 10 to column 11. The first function is an anonymous function because I'm defining that with the arrow function. So it's saying it's an anonymous function, and it goes from this line to this line, right? So this is how it keeps track of all the lines that are executed. So, and after it finishes executing everything, it will update the global object that it keeps where it keeps track of all the information. So what we need to find at the end of the processing is the value that is being tracked here in this global variable. It's not magic or anything. It's just like you see, it's just adding one counter before each line, and it's just incrementing that line by one every time it's run. So let me go back to the steps. So the first thing we need to do is, after we add the loader, we need to configure Webpack to actually apply to use the loader to apply the instrumentation for each of the files. And here we define the extensions of the files we want to instrument. So if the file we are testing is one of these types, we are going to call the Istanbul instrumenter loader, and it will modify our files during the bundling process. So I'm going to add this to the config. Can you read this screen? I don't know if maybe this is too small. Let me increase that too.
Yeah, it's fine.
No, it's fine.
Okay, so I'm going to add that configuration in Webpack environment. I can add that just here. So one thing is I'm adding this in the environments.js. For some reason, the test.js is not run when we run the test. I guess it's some bug in Rails. I don't know. For some reason, it was never being executed. So I add this conditional here. I add in the environment, and if the environment is test, I add these things. We add that. That's one problem I found when working with this thing. Okay, let's do one more test. I'm going to just rerun the application now, but in the test mode. So Rails and test and node and test, and we can see how the code coverage is getting measured when we use the application, right? So let me go back. Let me reload this. It should be compiling everything. Doesn't like the test mode. Let me change this. Just find this every time. Have the application running. Now it's compiling the JavaScript because we have the instrumenter now. So you have to recompile everything. Okay, now we have the application. And if we check the window.coverage object, we have the information for all the files, and we can inspect. Let me, it's too big. So each of the keys is one of the files that we have. And if I expand, I don't know, this one, we have the same information: statements, functions, branches. And for example, here, this statement number 4 is not executed. It was executed zero times. But if I click the TypeScript React component, is this one, and I try this again, I go to the TypeScript React, and you can see now that the 4 increased by 1. So this is how it keeps track of everything, right? What we need to do is at the end of all the tests, we need to get this variable and dump this information into one file. So let's continue with this. I'm going to revert this change so it's only running during the test. The next thing we want to do, we want to get the JavaScript coverage when we run the test, the Ruby code coverage too. So we have everything in one command. We have all the information we need. So I'm going to add simple code. It's a really common application to get code coverage on Ruby applications. So I'm going to add this into the, I can add that here because it's not being required, so it's fine. And one thing we want to do is in the environment, when we are running the test, we are going to require simple code. But only, let me show you that. Environment test. We do that. We have to do this as early as possible because we need to instrument the Ruby code too. So we do that here at the top of the test environment file. And we are going to do that only during test and only if we want to get the coverage, because this impacts in the performance of the application. We don't want to always get the code coverage of everything. Sometimes we want to run the test faster, so we can do this. And maybe in CI we can turn this on by turn only on CI, and we always get the code coverage on CI. The next thing we need to do is we need to tell simple code to start. I could add this line here, but since we are going to add more information to the simple code configuration in a moment, I'm going to move that to one configuration file for simple code. That's the .simple code file. Simple code will take care of reading this thing when needed. And this is just Ruby, but it's just missing the formatting because it doesn't have an extension. But this is just Ruby code inside this file. So the next thing we need to do is if we run the test right now, we are going to get all the information, but we are only going to get the information for Ruby, right? We are going to have simple Istanbul running, but we don't get that information. We need to extract that information from the window object. And this is the part that is a bit tricky. So what we need to do is after each test, we need to read the window object from that run and save that information to a file. So to do that, we are going to use this helper function. It's I'm going to explain what it does in a moment. And another thing we want to do is we want to prepare some directories that we are going to use for the JavaScript code coverage. So we do that here. So only if we want to get coverage, we are going to initialize simple code and initialize the directories we need for NYC or Istanbul. So the function we are going to use to get the dump is this function. Is the first thing is just a guard clause. It's just if we don't have a coverage, we just ignore this function. Then what we do is we use the page object from Capybara, and we do evaluate script, and we get a string version of the window.coverage variable. We save that into a variable. If we don't have any coverage, we do nothing. And if we have some coverage information, we will save that file somewhere. One tricky part is that we are going to run this after each test is done. So we are going to have a lot of these files for each test. So we are going to use a random number generator here, just so we have multiple of these files. And then at some point, we are going to merge all those in one big file. Because we have to do that because after each test, the browser that Capybara is handling is cleared and it starts again. So we lose all that information. So we have to save that information every time. Okay, so the next step is that we need to configure the tests. So it will actually call that function after it tests, right? So in Minitest, the way we do that is we can extend the application system test case class, adding this function, this method, and this method is part of the life cycle of the tests in Minitest. It's before teardown, so it means that this is run before the test is teared down from the execution. There is another callback that is after teardown, but that happens too late in the process. That's after the browser is closed. This is before the browser is closed. So for Minitest, we are going to add this this callback, and we can go here in the test folder for Minitest. We have the application system test case class. This is default Minitest configuration, and we add that here. With this is the only thing we need for time with Minitest. It will just run this after each system test. For RSpec, we need to do something similar, but we have to use, there is a way to add an after hook for each test in RSpec, but it's not working properly. I opened a ticket in the RSpec Rails repository, but the maintainers gave me this solution that we can use for now. Instead of adding an after for everything, we use a shared context, and we include the context for our system test. So we are going to do the same thing here, but for RSpec. And here in RSpec, we do that at the top of the before the rspec.configure. We do that here. And we need to include the shared context in the system test. If we have feature tests or integration tests that are not system tests, we can add more lines here doing the same thing. As long as it uses Capybara, we can get the information from that, and it's running the JavaScript, because sometimes you can run integration tests without JavaScript, right? Okay, so after we have this, that's the part of extracting the information, right? So let's run the test with that change and see what happens. So let's run overrush. Overrush true. Rails test, and we mean the test, we can add the test. Also, it runs the test system, so it runs the system tests. So after a moment, we will run everything. That you can see it's just
I guess we need to define that.
Oh, I forgot to say the file.
Oh.
Again. So it ran everything, and we can check that it created this NYC output directory, and inside this, let's see. YC, I can see that here. Okay, that didn't work. Let me see what's going on there. Let me try with the RSpec test. Great, it didn't work. Let me see what's going on.
Is it possible that there are dot files and they're hidden in Finder?
Oh, maybe.
If
No,
you...
but I see them here.
Oh, okay. Oh, you see that, yeah.
Let's see what's, let's have that pipe call there and see if that's being called. Working. Oh, it's being nil. Great. Oh, I think it's probably something with the cache of Webpack. It doesn't like to recompile the JavaScript during tests. So let me clear that. Lower. Let's try again. So next. Oh. Oh, great. It's not working here. Let's see if we have the instrument code here. Okay, something's wrong with the loader because it's not even there. So come back here, and I'm going to remove this for now, just to make sure this is not affecting anything. Let's run it again. Because yes, there is something weird going on with Webpack and the test environment. I think that's it, but let's see. So we have that now. There is some issue with Webpack and the test environment. So let's continue. And now if I go to that folder, I have one JSON file because we have in the RSpec files, in the RSpec test, we only have one test. So if I come here, I have a system test and I have only one test. But if I run the mini test, in this case, I added two files. So it's going to generate in this, we have two files and each of those have one test. So we're going to generate two JavaScript, two JSON files, right? So I run that, I do test system. Remove the bypass folder. Doing funny stuff. Let me remove that bypass call. Run it again. It runs everything. And if I go back to that folder, we have two files. So what we need to do now is we need to merge these two files into one big file so we can get the complete metric, right? We don't need to do anything. Let me go back to the presentation. So we added Istanbul. We talk about that. We are collecting the data. For single code, the gem takes care of everything. It internally instruments everything and keeps track of everything, but we need to do that for Istanbul with the thing we were doing right now. Now we need to process all the data. We need to merge all the files into one big file. So to do that, Istanbul comes with a merger tool. So we need to have Istanbul added to our package. And we need to run the nyc merge command. This is prepared to use the nyc output folder, and it will generate an out.json file with all with the complete output of with the merge of all the tests. So if I do that manually, I'll go run yarn nyc merge everything. I run that, and it will grab all the files inside that directory, and it will create one out.json. And this one is the combination of those two, right? And the next thing we want to do with that is we want to generate an HTML report. So we are going to do, I'm going to add these configurations just so I can specify the directory where I want to have that coverage, because simple code by default creates the coverage directory, and just for consistency, I'm going to create a folder called JS coverage. We don't need to create the folder, but we need to configure nyc so it creates that folder for us. So here I'm going to add the report directory is going to be JS coverage. So now if I run nyc report, in this case, I want to generate an HTML report because it's the same thing that simple code is doing by default, but we can configure this to report like a text-based report. So we can use in CI, for example. So I'm going to run this command and yarn nyc report. This is going to read by default, it's going to read the nyc output.out.js file, and it will generate the JavaScript report. So let's see that. It's here. We can open the index files in the browser, and we have the cover, right? And if we go here, we can see, for example, that in this file, we executed every line because it's one of the test files. In this file, we executed everything because we are testing this thing. But in these two files, since we are not clicking those buttons, we are never running these functions. So this is not being tracked, right? This is a similar report that we get from for Ruby here in the coverage folder. We open this and we have a similar report for all the Ruby code. One thing is there is a problem with simple code and mini test and parallel testing. So this shows up with everything as 0, even though the Rails application runs. So we should have some coverage. So if you happen to use mini test, I recommend you come here, and instead of using number of processor here, if we want coverage, we run only in one processor. This is a super naive solution. I think there are more complex solutions in the simple code issues tracker, but for now this works fine. So I'm going to do workers equals n coverage. We are going to do 1, and if not, we are going to do number of workers. And if I run the tests again, and I refresh the code coverage here. Now we have some coverage. It's a super simple application, so it has nothing really important here, but at least we have some coverage, right? So everything is working. With that command, we have the two. We can get the 2 reports. So the last part is of this is we don't want to run these commands manually every time, right? We want that to be generated at the end of their test run, and that's it. So to do that, we can come here, and we are going to use the callbacks that Simple Cov already provides. That's telling us, okay, the test finished. So we are going to add in the Simple Cov file, we are going to add this code, this block code. I'm going to explain what it does. So what this is doing is, by default, when we run Simple Cov, by default, it has internally a simple code at exit block that it just runs this thing. That's why when we run simple code, we already have the report created, right? Because it by default is running that. But we can override that callback, and we can run simple code result format because it's the default thing, and we can also run the yarn command any yarn command that we want. Here we could say yarn nyc generate report, whatever. But what I like to do is when we use yarn or npm, we can create custom scripts so we can just run yarn with a name, and it will execute our script. So we can go here to the package.json, and we add a new key in this configuration called scripts. And here we can script, and then come back here, and we add the key is the name of the script we want to run, and then we add all the functions, the commands that we want to use using yarn or npm. And now, instead of running those 2 commands manually, we can first we can run here. For example, we can do yarn coverage, and it will run those 2 commands for us. But now we configured simple code to do that at the end of the test. So when everything ends, it will generate the simple code report and the JavaScript report. So let's go back here. Let me remove the information just so it's clear that it's not using all the information. So when I run the test now again, it should create the coverage folder, the JS coverage folder already with both reports there. Everything's there. If I come back here, I can see in here it created the NYC file directory with all the files for each run, the out.json, the coverage folder with the Ruby code, and the JS coverage folder with all the JavaScript code. Yeah, that generates all the reports. One extra thing we could do is, for example, let's see, I think it's continuing here. Command. We already saw the reports, and one thing you could do, for example, is you could also use simple code and yarn and Istanbul commands to measure your code coverage on CI, and if you are below some threshold, you can fail, for example. I haven't tried other JS bundlers, so I imagine it may work with ESBuild, but I haven't tried that. It depends on how loaders are, how compatible are loaders between ESBuild and other build and between Webpack and other bundlers. And there is one issue with view files. I'm still doing some research there, but since view files are not JavaScript files by default, Istanbul lose track of the file name with the coverage. It can track some coverage, but then it cannot dump that information to give us a report of the file. So that's what's next for me to do some research there. So there are some limitations of this of measuring the JavaScript code coverage. Like I said, when the test ends, every time we change the window object is initialized, we lose this information. So if we change screens or we reload the page, things like that, we lose this information. One trick we can use is if we use things like turbo or turbo links that won't do a real complete page loading event. So it will keep the window coverage object there. So that's one thing we can use. Instead of just doing normal HTTP requests, we can use turbo links to fake those things using JavaScript in Ajax. Another option is that you are careful and in your test, instead of just calling this thing at the end of each test, if we want to take the metrics in some points, we can just have this function and add that to any test in any place. If we add that, I don't know, here, this will dump the window object in the coverage object into a file, and that will work. Sometimes, I know, if we have a visit route right here, and at some point maybe it's a long test, and we again do visit some other path, maybe what we want to do is, before doing that, we add this thing right before the visit, for example. That's an option. And that way you keep track of everything and not only the last thing the test is seeing. Another option would be to have a way for Capybara to listen to the window on before unload event. But currently there is no way with Capybara and Selenium to listen to the page events. So that's not an option yet. I'm trying to do some research there to see if there's a way to connect to that. And if that's the case, we could have every time that the window is unloading, we just dump that. And that would be, I think that would be the best solution, because we won't rely on anything. We will just, every time the window is unloading, we get that information. If lines are repeated, it's not a big deal, because we don't care about how many times things are being executed. We care about that things are being executed. If how many times is a different kind of metric you want to take. Maybe you want to see, I don't know, if your test is is fine if it's running something too many times, but for the coverage, we only care about one or more times. Let me see if I'm missing something. Okay, right. Oh, one more thing we can do is right now I'm just testing these two things, right? But if I want to test, maybe let's try to click the TypeScript hello Philly instead. Hello Philly. So because of this configuration we have here at the top of the test.rb, it will clear the previous runs, so we don't have to worry about all data mixing our result, giving us false results. So when I run this again, let's run this system. It already generated everything for us. And if I come here and I open coverage here, I come back here, and now our TypeScript, this file is 100% because we changed the test, and now the vanilla React it's failing because we are not clicking that, so we don't have a coverage here. But this is just to show that it also works with TypeScript. And yeah, I think that's everything. I don't know if you have any question or anything for me.
Awesome. Thanks for your presentation. Do we have any questions for Ariel?
I'm curious just about the motivation for it and how you figured it all out.
Yeah, the motivation is we've been working with Fiona on a React application, right? And it was just a React application. There was no backend or anything. And the front-end code can be really complex if you want to. And I know there are a lot of Rails applications. It's super common to use modern JavaScript frameworks now. And I don't know, Vue, Angular, React are really popular. And I've seen a lot of people saying, oh, you should use Ruby on Rails for an API only on the backend, and then you make a React frontend, for example. And the frontend is what the user is actually interacting with, right? So you want to make sure that you have a good coverage of that. You want to make sure that you have a good test suite that stresses what the user is using. And one good metric is to check the code coverage, because like I said at the beginning, it's not that 100% code coverage is going to say, oh, you are a really good test coverage, because a really good test suite, because you can have really bad tests just to run one line, and that's not a good idea. But at least it gives you an indication of things that you may be missing, and you can say, oh, I'm never testing this path of code, and this is really important for my users or my application. So we usually don't get that coverage from when we run Rails tests, right? So the motivation is to have more, to be more confident when with our test suite. It gives us more confident. It makes us more confident to actually change stuff, because right now, I know if we go and change something in the backend, we don't know if maybe we are breaking something in the front end and we don't know. Maybe we don't have tests in the front end for that, and we are breaking that and we don't know because we don't have tests. Because if we got tests and we break that, we know because the test is broken. But if we don't even have tests for that, that's a problem. Oh, sorry, you're muted.
Sorry, thank you. Yeah, I think maybe my question wasn't clear. Like, I definitely understand the motivation for having the tests, but like the motivation for like, you know, sort of combining it so you can basically make a single call to sort of run all your test coverage. Like doing this as opposed to just having like whatever tools you're using for your JavaScript tests just run completely independently of the tests you're doing for your Rails backend tests.
Yeah, the motivation there was that we are already running front-end tests when you run system tests, right? And I know some people may like to add, I don't know, maybe they add Cypress, which is a JavaScript testing tool. And maybe you have a test suite for backend and one test suite for Cypress. Personally, I like the idea of writing all the tests in the same language. So when I write the code, every test is run with is written in Ruby, right? And so the front-end test is Ruby and the backend test is Ruby. So it's just one language that you need to understand to write all the tests. And then you don't need to maintain two different test bases, and you don't need to run two different reports. You just run one command. It runs everything, and you get, because I mean, personally, I really like automations and having to run as less commands as possible. So yeah, that's the main motivation, not having to, being able to just write Ruby code, Ruby tests, and get the same information that we could have with front-end tests with Cypress, for example. And how did I figure all this out? I found a blog post that was doing part of this. Other things were just, I found a blog post that was doing this main thing, that the first part, that this function, I found it in a blog post, but it was only using RSpec, and it was using a different version of RSpec, so some things were not working. And I wanted to attach everything to simple code too, because it didn't have automations. It was just, okay, you get this information, and then you have to run these commands to get the report. I wanted to make everything in one command.
Cool. Thank you.
Right. Thank you.
Yeah, I really like the idea of running everything in one command. Have you thought about like what it would take to extend like simplecov to do like a simplecov - JavaScript that somehow took care of this? And like, you know, simplecov has the HTML report that you showed, and it shows the data for all the Ruby files. But is there, or how hard do you think it would be to do like simplecov - JavaScript that kind of like uses the Istanbul library to do all this thing that you did, and then it kind of includes the JS files inside the same simplecov HTML report?
Yeah, I think the most tricky part will be to make simplecov aware of your JavaScript bundling process. Because right now, when you run the application, the Ruby application, it runs. And when you want, the way Ruby on Rails work right now is when you want to run the test, when you want to access some asset, it will compile that then. That's a different thread, right? So I don't know if simplecov have visibility to change the way Webpack is processing your JavaScript. Maybe there is some way to do that. I don't know. Maybe one thing that can be done is when we use simplecov with --JavaScript, for example, it will run Webpack for you. It will compile your assets, and then it will run the test. So you already have the assets compiled by simplecov. But then another problem I had is what I was trying first was to get the report from Istanbul and merge that with the report from simplecov and have everything in one place, but it's a different format. So we will need to have some kind of translation between the Istanbul generated files and how simplecov understands them. And I don't know if there are any weird edge cases that people should take care of, but I think that part is possible. If you get all the JSON files from Istanbul, there's probably a way to translate those into the format that simplecov expects, and then you just run simplecov format and you get one big HTML report with everything. But I know what's the complexity of that, but I know it's possible because you have just JSON files, right? You just need to change the syntax from one to the other one. I think that the hardest part is making sure that simplecov can compile your assets with Istanbul added in the process. But yeah, it's one idea I had. I think it's really interesting to do more research there. I'm just not sure how. I haven't thought about how to actually do that connection. But yeah, that was my first idea, to have only simplecov do everything, but it didn't work. One thing, if you go to our GitHub organization, we have in GitHub/fastruby/JS coverage sample app. This code is there if you want to see that. And the link here is not complete, but if you go to our blog, it's FastRuby blog, you can see that. Right now it's the first one, but you just go for JavaScript test coverage and everything is there. All the steps are here. I will update this thing because we had some issue here. So I will do something like, just to make sure that it's not running maybe in production or development, I will debug this thing. But yeah. Okay, that's it. Then I don't know if there's any more question.
Cool. No, just to add to the SimpleCov JS idea, is like I found an issue in SimpleCov that it seems like the team behind it was interested, but they were just like, oh, it's too complicated, so we're not going to do it. But I think anyway, it would be pretty cool to have something like this and quickly gauge the JS code coverage metric in just one report.
Yeah, I think there's also one thing that I was doing here. Like I said, I did this change for SimpleCov just to work with parallelization and Minitest here. And this is just one solution I came up that is quick because right now we have only a few tests, but you don't want to do this in a big application. So yeah, I think this is related to that. Like because right now what we are doing with JavaScript, we are merging all the reports into one file. And one solution I saw in the SimpleCov issues tracker is that what they want to do is to fix this parallelization issue is they want to dump each run of each parallel execution of the test and then merge all of the Ruby test code at the end. So it's a similar idea they want to do with to fix parallelization.
Cool.
I know, Luciano, are you saying you want to say something or are you saying bye?
No, I'm saying bye.
Okay.
Bye. Cool. Thanks, Ariel. Any other questions for Ariel? All right, cool. So awesome. And if anybody wants to follow you, what's your Twitter?
Oh, my Twitter is my Ariel, my name, and the first 4 letters for my last name, Ariel Juod. And in GitHub, I'm Ariel J.
Cool. All right. Well, thanks a lot for your talk. It was really interesting, and I feel like we can all use this in our applications like tomorrow. So thank you.
Great. Thank you all. Thank you for inviting me.
All right. Have a nice day.
Bye.
Bye-bye.
Thank you.
Bye.
Bye.